Have you ever looked up at the night sky and wondered, what lies beneath the swirling clouds of Jupiter? What if I told you that what we once thought was just a giant ball of gas is now revealing signs of structure, depth, even motion that feels almost alive? These aren't special effects. These aren't simulations. They're real images, captured just weeks ago by spacecraft orbiting 500 million miles from Earth. And they're unlike anything we've seen before. Storms the size of continents, clouds that twist like ocean currents, a planet that doesn't just spin, it pulses, breathes, changes. And then there's Io, a moon so volcanic it literally erupts into space. It's not science fiction, it's our solar system. But here's the real question. If a planet like Jupiter, once considered a chaotic gas giant, can be this complex, then what else is waiting to be discovered? In the next few minutes, we're diving into the most stunning, most bizarre real images ever taken of Jupiter, and the mind-bending secrets they're revealing. Because what you're about to see might change how you view the universe, forever. For centuries, Jupiter was a mystery, a distant swirl of colors seen through telescopes too far to reach, too massive to explore. We called it a gas giant, a label that suggested chaos, vagueness, and a lack of solid ground. But that perception is changing, fast. Thanks to an unprecedented collaboration between three of humanity's most powerful tools, NASA's Juno spacecraft, the Hubble Space Telescope, and the James Webb Space Telescope, we're now seeing Jupiter like never before. Juno has been orbiting the planet since 2016, diving dangerously close to its turbulent atmosphere. It's capturing high-resolution images of storms the size of continents, of clouds so detailed you can see their shadows. Hubble, watching from afar, tracks the planet's long-term weather patterns in visible and ultraviolet light. And Webb, with its infrared vision, is revealing hidden heat sources, deep jet streams, and even auroras wrapping around Jupiter's poles. Together they paint a stunning portrait of a world in motion, not just swirling aimlessly, but pulsating with energy, structure, and mystery. And it doesn't stop with Jupiter itself. Juno recently flew past Io, the most volcanically active object in the solar system, and two new missions, ESA's JUICE and NASA's Europa Clipper, are already on their way to study Jupiter's icy moons. These moons may hold liquid oceans beneath their frozen crusts, oceans that could, just maybe, harbor life. We are no longer outsiders looking at a gas giant from afar. We're finally stepping inside its atmosphere, touching its storms, and decoding its ancient rhythms. Imagine a single storm wide enough to swallow Earth whole and powerful enough to last for centuries. That's the Great Red Spot, a hurricane so massive and ancient it's been raging since the 1600s. Now picture entire clusters of these storms, each one the size of a continent, swirling like petals in a flower across Jupiter's poles. Back on Earth, our strongest hurricanes last days or weeks. On Jupiter, they endure for decades, even centuries, fueled by an endless supply of heat and energy from the planet's deep atmosphere. Our skies rain water. Jupiter rains ammonia. Our weather has boundaries: land, sea, air. But Jupiter has no surface. Its atmosphere stretches down for thousands of kilometers, with storms that don't just spin, they sink, rise, and twist through layers like a planetary ocean of clouds. And then there's Io, Jupiter's moon, about the same size as Earth's moon, but wildly more active. While our moon is silent and gray, Io is a world of color and chaos. Volcanoes erupt constantly, launching plumes hundreds of kilometers into space. Its crust is torn and twisted by Jupiter's gravity like dough in a giant mixer. Where Earth is stable and calm by comparison, the Jupiter system is wild, ever-changing, and larger than life. Jupiter isn't just a bigger planet. It's a more extreme reality, one that stretches the limits of weather, physics, and imagination. We're not just watching Jupiter from afar anymore. Humanity has sent its robotic explorers deep into the heart of the gas giant's domain. and what they're uncovering is rewriting everything we thought we knew. At the forefront is Juno, NASA's resilient spacecraft. Since 2016, Juno has been flying in a wildly elliptical orbit around Jupiter, diving just thousands of kilometers above the cloud tops. With each pass, it captures jaw-dropping images of cyclones, jet streams, and atmospheric layers, data so rich that scientists and citizen image processors alike are discovering new details with every download. But Juno is just the beginning. Two major missions are now en route to expand our exploration: JUICE from the European Space Agency and NASA's Europa Clipper. JUICE will study Jupiter's three largest icy moons, Ganymede, Callisto, and Europa, all of which may contain underground oceans. Ganymede, the largest moon in the solar system, even has its own magnetic field. JUICE will be the first mission in history to orbit a moon other than Earth's. Meanwhile, Europa Clipper will focus on the most promising candidate for extraterrestrial life in our solar system, Europa. Using radar, spectrometers, and atmospheric sensors, it will search for chemical signatures of life beneath the moon's icy crust. These missions are not just scientific checklists, they're acts of ambition, humanity reaching into the depths of a distant world, searching for our cosmic kin, one frozen moon at a time. Let's imagine for a moment. Beneath Europa's thick crust of ice, which could be up to 30 kilometers deep, lies a global ocean. Not puddles or lakes, but an entire ocean, possibly twice the volume of all the water on Earth. Now imagine that ocean isn't still. It's warm from within, stirred by tidal forces from Jupiter's immense gravity. It's dark, isolated, and ancient, untouched for billions of years. And yet, it may not be empty. On Earth, we've found life in the most extreme environments: deep-sea hydrothermal vents, frozen Antarctic lakes, caves without sunlight. Life, simple, resilient, and tenacious, always finds a way. So what if, in the oceans of Europa, life also found a way? Not aliens with spaceships, but microbes, or complex underwater ecosystems feeding off heat and minerals. Creatures that have never seen the stars. Life that evolved under pressure, literally and figuratively. Europa Clipper won't drill into that ocean, not yet. But if it detects plumes, chemicals, or unusual energy patterns, it could be the first indirect evidence that we are not alone. And if we find even a single microbe, it would change everything. Because life, then, wouldn't be rare. It would be inevitable. It would mean the universe is not empty. It's alive. It's easy to look at these images and think, that's beautiful. And they are. But beauty is only the beginning. Every swirling storm, every shifting color band, every glowing aurora is more than just eye candy. They're signals, clues, messages from a planet that has been whispering through space for billions of years, waiting for us to finally listen. Jupiter, once a distant blur in our night sky, has become a world of its own, dynamic, layered, alive in ways we're only beginning to grasp. Its storms don't just rage, they breathe. Its moons don't just orbit, they evolve, erupt, and interact. And beneath layers of ice and gas, something ancient may be stirring. The images we're seeing today, some processed by citizen scientists, some delivered from telescopes billions of kilometers away, are more than technological triumphs. They're emotional ones. They connect us across time and space to something far greater than ourselves. And they raise a question we can no longer ignore. If one planet, in our own solar system, can be this rich, this strange, and this alive, then what about the hundreds of billions of other planets we haven't reached yet? Maybe we're not just exploring the universe. Maybe we're meeting it for the first time.